Hi! This instructional video is about factoring quadratic expressions. Factoring quadratic expressions. There's something unique about these expressions, however. They're part of what you call a special product property. Special product property. Let me show you what I mean once I factor these guys. Start with number 1. First, when we do the AC factor method, you need to ask yourself, what times what would give you x squared? And you will say, well, x times x. And then what times what could possibly give you a 9? And you could say, of course, 1 times 9 is a 9. And 3 times 3 is a 9. And the next question is, of course, if you were to add or subtract those possible combinations, what would give you a positive 6, the B factor? Well, you need to add 3 and 3, and they both have to be plus. And here's the thing. When you do that, you notice they're two identical binomials. And so these are called special product property because every one of these that you factor will turn out to be identical to each other, and they're called a perfect square. Trinomial. Or we call this the square of a binomial, that is. And sometimes you could write this as x plus 3 squared, because they're identical. And, well, that's a good answer, but I would usually put it together as one expression. So why don't you try number 2 and 3 then? Okay, so you said, well, here we go. What times what is x squared? X and x. Now that we know the trick, that these are perfect square trinomials, what same number if you multiply will give you 16? And if you add them together, it will give you negative 8. And you will say right away, it's going to be negative 4 and negative 4. Because negative 4 times negative 4 is positive 16. And if you add negative 4 and negative 4 together, it will give you negative 8. And if you wanted to, of course, you could write that as one expression, x minus 4 squared. And this one, you will say, it's getting too easy now. X times x is x squared. And what same number adds up to become 18? You'll say 9 and 9. So that's another way to look at it. And if you multiply them, we'll give you 81. In this case, if they're both positive. And of course, you could write that as one expression, x plus 9 squared. So that's it. Not quite. So now, if you were given those perfect square trinomials as an equation, how would you solve it? So let me give you a little demonstration for number 1. Again, we know, just kind of by, well, since we are told, we're going to solve this by factoring. And here we have 4x squared, perfect square. And you know what times what is 4x squared? 2x and 2x. What times what is 1? 1 and 1. And look at this. 2x times 1 will be 2x. 2x times 1 will be 2x. And if they're both negative, they would end up being negative 4x. And negative 1 times negative 1 will give you positive 1. So that's a proper factorization. And since they're identical, you could either use a zero product property, which you should, or you could write this as a single expression and solve for x. So in this case, you would square root, because that's the inverse of a square, to both sides of the equation. We got 2x minus 1 is equal to still a 0. And 0 is not a plus or minus. And then you would solve for x by adding 1 to both sides. So we got 2x is equal to 1. And then divide the 2. X equals 1/2. Yep. Now number 2, same thing. Why don't you do 2 and 3? Alright, so you said, looks like a perfect square. Trinomial, I could feel it. What times what is 25? 5 and 5. X and x will give you x squared. What times what is 1? 1 and 1. But 5x times 1 is 5x. 1 times 5x is 5x. What must their signs be to add up to become 10x positive? They both have to be positive. So this is plus, this is plus. Now, since these are two identical binomials, can I just simply take just one of them and use a zero product property to solve? Yes. So if you do -1 to both sides and then divide the 5, you end up getting x is equal to -1/5. A little faster now. Here we go. Perfect square is 9, 3 and 3, x and x. 5 and 5 is 25. They both must be negative, which will add up to become 15, and 15 is 30 negative, and they're positive if they multiply. So you just take one of the binomials, use a zero product property, add 5 and divide 3, x equals 5/3. There you go. Special product property, perfect square trinomial.